So section for review, it's through completing the square. On the first 10, you are solving by factoring. So remember, when you are using factoring to solve, you have to get your problem set equal to 0 and in standard form. So let me do the first one with you. So on the first one, I'll subtract 3 from both sides. Zoom in. And that gives me x squared minus 2x minus 3 equals 0. And you have to determine A, B, and C once it's set equal to 0 and in standard form. Okay? So A is 1, B is -2, C is -3. Make your little T-chart. I need two numbers that multiply together to give me A times C. In this case, A times C is -3. And I need them to add together to give me B, which is -2. All right, let's see. -3 times +1 is -3. -3 plus 1 is -2. So that works, right? So I have x minus 3 and x plus 1 equals 0. Don't forget, you have to divide and slide by whatever A is from your T-chart. If you had a GCF, your A in the T-chart is going to be different than the A that you were originally given. But if you don't have a GCF, they'll be the same. Okay, but if they're different, always use the A from the T-chart. If I divide and slide by 1, is that going to change anything? No. So is it necessary? No. So I have factored here, but I have not solved, which is what it asked me to do. So to solve, once you're finished factoring, set each factor equal to 0 and put it in standard form. So I'll set x minus 3 equal to 0, and I'll set x plus 1 equal to 0. And I'm kind of running out of room. So if I were to add 3 to both sides, my answer would be x equals +3. A lot of students are still telling me that x is equal to -3. Okay, they're just looking at whatever's in the parentheses and taking that sign. Be careful of that. If you set it equal to 0, it's going to change the sign. And then over here, if I subtract 1 from both sides, my answer is x equals -1. Everybody cool with that? Okay, let's look at number 6. Okay, if I'm factoring, I got it set it equal to 0 and in standard form. So I will subtract 12a from both sides. And I get 2a squared. Now don't write plus 16 minus 12a because that's the order that you see it. That would not be in standard form. That minus 12a should come next, and a constant always comes last. Now, I forgot to ask this question on the last problem because I just knew there wasn't, and I forgot to ask, but I should have. Is there a greatest common factor? Yes. If there is, factor it out. And what is it? 2. So I'll factor out my 2. And I get a squared minus 6a plus 8 equals 0. Now make my little T-chart. I need two numbers that multiply together to give me AC, which I didn't define A, B, and C. What is A? What is B? -6, and C is 8. So A times C would be +8. And I need those numbers to add together to give me B, which B is -6. -4 and -2, you say? Let's check it out. I'm trying to find a pen that writes thinner. -4 times -2 is +8. -4 plus -2 is -6. That works. So I'll have a minus 4 times a minus 2 equals 0. Again, I divide and slide by a. A from the T-chart's 1. The original A was 2. If you divide by 2, your answer is not going to be correct, okay? We're not factoring that original problem anymore. We are factoring A squared minus 6A plus 2. I'm making all kind of mistakes this morning. 3-day weekend. Up here, wasn't I supposed to write the GCF outside the parentheses? And right here as well, write the GCF. Now, if I'm solving it, that would not have hurt my answer because that GCF does not give me an answer. But it's not good form in math to just forget it, okay? Because if I just had to factor and I forgot that, then that would make my problem incorrect. But if I'm solving it, it doesn't, okay? But don't forget it because it's there. Now, if I divide and slide by that 1, we already know that's not going to change anything, okay? So I'm not going to worry about it. So now I'll set my factors equal to 0. So when I set 2 equal to 0, while 2 is a factor, it does not give me a solution because 2 does not equal 0. It does not have a variable. If the GCF was a variable, then that would give me a solution. Set A minus 4 equal to 0 and set A minus 2 equal to 0. So here, when I add 4 to both sides, I get A is positive 4. And when I add 2 to both sides, I get A is positive 2. And those are my answers. Everybody cool with that? All right, let me do number 10 and then I'll be finished factoring. Number 10, it's already set equal to 0 and in standard form. Yay. Is there a GCF? No. All right, so then I can go right to my T-chart. What is A? 2. B is 9 and C is 9. So I need two numbers that multiply together to give me A times C, which A times C is positive 18. And on the right side, I want those same two numbers to add to give me B, which is positive 9. All right, let's check it out. 6 times 3 is 18. 6 plus 3 is 9. So that works. So I'll make my parentheses. And in my parentheses, the variable they're using is x. So x will be the first term in each set. And then I look at my T-chart. I have a positive 6 and a positive 3. Those are the two factors that made both sides true. Now this time, is A going to be a 1? No. So it is important that I do the old divide and slide. Remember, if you can divide evenly, you divide. If you can't divide evenly, you slide. But if you slide and you can reduce first, you must. So 6 halves, is that going to be a divide or a slide? Divide. And I get x plus 3. 3 halves, divide or slide? Slide. Now, if it's a slide, I have to reduce if I can I? No. Nope. So I'll slide the 2 on over and put it in front of the x and just bring down the plus 3. Once I divide and slide, it should be completely factored. Just double check. If you do a first times first, you should get your first term. X times 2x, is that 2x squared? Yes. Your last term times your last term should give you your last term. 3 times 3 is 9. To know if you divided completely correct, you have to distribute the whole thing. But if you at least do a quick check, like up here, if you forgot to divide and slide and you did a quick check, does your first term times your first term give you your first term? No. Does your last term times your last term give you your last term? No. So that should have let you know something's wrong. Oh yeah, I forgot to divide and slide. Okay? So now when I set each factor equal to 0, here I'll subtract 3 from both sides, so my solution will be x equals negative 3. On this equation, I'll subtract 3 and then divide by 2, so x equals negative 3 halves. And I'm just out of room, so I'm not showing that. Any questions on that? I feel like we factored a lot. So I'm hoping that you're all good there. And what do you notice about number 9? What is it? You mean two terms? Yeah. Two terms. Does it have a GCF? No. It's a difference of two squares. Remember, you have special cases that you're going to run into sometimes, but I'm not factoring that one for you. All right, 11 through 14, you are solving by completing the square. We just did that for homework. I will do one of them for you, though. I'm going to have to use a separate sheet of paper because there's no way I'm going to get all that on that tiny little spot. So I'll do number 11. So remember, when you are completing the square, it's different than factoring. It doesn't matter if there's a GCF, okay? It doesn't matter if it's a special case. If you're completing the square, you're not trying to get it set equal to 0. You're trying to get your constants all on one side. That's the first thing you do. So that's different than factoring. So I'll start off by subtracting 26 from both sides. So I have a squared minus 14a equals negative 16. Now, if a is anything other than 1, we have to divide every term by a. But in this case, a is 1, so we don't need to do that step, right? But don't forget it, because say a is a 2. Well, if you're trying to complete it, make a perfect square trinomial on the left side, if you have 2a squared as your first term, is that going to make a perfect square trinomial? No, because it's not a perfect square. So don't forget that step, because you're trying to make a perfect square trinomial. So to do that, it's called completing the square. We take whatever b is, we divide it by 2, and then we square it. So b is negative 14. Negative 14 divided by 2 is negative 7. And negative 7 quantity squared is a positive 49. So we are adding 49 to both sides of the equation. Both sides. So now we have a squared minus 14a plus 49 equals negative 16 plus 49 is 33. Did I create a perfect square trinomial on the left side? Do y'all remember how to tell? Okay, so let's just do that. I know I did because I did completed the square, but let's just reminder. It's got to be a trinomial, right? We're only looking at the left side. Is my first term a perfect square? Is my last term a perfect square? Yes. Is C positive? Yes. Does that mean that it's a perfect square trinomial? No, you have to check the middle term. To check the middle term, you take the square root of the first term, which is a, square root of the last term, which is, multiply those two square roots together and you get 7a. Double it and you get 14a, which is that the middle term regardless of the sign? Yes, then it's a perfect square trinomial. So we know to factor that, it's going to be two identical factors. So that's why we just make one set of parentheses, but we square it. The sign will be the sign of b. The first term is the square root of the first term. The last term is the square root of the last term. Not looking at the other side of the equal sign, okay? So the square root of 49 is 7. So our whole goal is to solve for a. A is inside parentheses, it's being squared. So to undo that, the inverse of squaring something is taking the square root. And what we do to one side, we have to do the other. To the other side, we take the positive and negative square root. What's the square root of a minus 7, quantity squared? A minus 7 equals positive negative. Is 33 a perfect square? No. Does it have any perfect square factors? No. If it did, we would need to break it down. Okay, like when that was a 27 on our homework, we had to break it down. 33 does not have perfect square factors other than 1. 1 doesn't help. So we can just leave it as positive, negative, square root of 33. But I haven't solved for a yet. I've solved for a minus 7. So I can make two separate equations at this point, or I can just add the 7 now. Just be careful, don't add 7 to 33, okay? We would write this as 7 plus or minus the square root of 33. And I can't do any simplifying unless I change it to a decimal, and we're not doing that. It's going to be in radical form. If your answer was written as two separate answers instead of combined as one, you would have a equals 7 plus the square root of 33, and you would have 7 minus the square root of 33. So you would see that in one of these two ways, okay? Everybody cool with that? So on 15 through 18 on the back side, the program that I used to make this review, it wouldn't give me any radicals that had imaginary solutions. So, but I still wanted to know that you could simplify a radical. So none of those have imaginary solutions, but I still want to know that you can simplify it, okay? So none of these answers are going to have i's in them because they don't have negatives under the radical. But let's just do a little review on how to simplify a radical. Is it going to have an I because of this negative here on number 15? No, that's not under the radical, right? Is 252 a perfect square? All right, but it might have a perfect square factor. So that's a big number. I'm going to make myself a little factor tree. And I don't know many factors of 252, but I know it's an even number, so it has to be divisible by 2. It is, evenly. So that tells me that 2 times 126 gives me 252. 2's prime. 126 is also divisible by 2. So 2 times 63. 63 is not an even number, so it's not divisible by 2. What can I multiply together to get 63? 9 and 7. 7's prime. And 9, I get 3 times 3. So I just break it down until I get all prime factors. And then I put those prime factors in order. I have 2 times 2 times 3 times 3 times 7. That should give me 252. Let's check it out. 2 times 2 times 3 times 3 times 7 is 252. Okay. So if I have any two factors that are identical, that makes a perfect square. I've got another pair of identical factors, that makes a perfect square. So I could change that instead of 2 times 2 times 3 times 3 times 7, I could change that to 4 times 9 times 7, right? Well, did y'all remember, and I've told you this before, that if you multiply two perfect squares together, the result is also a perfect square? Y'all remember that? So 36 times 7 should be 252, which it is. So I'm going to replace 252 with the square root of 36 times 7. Did y'all know that 36 times 7 gave you 252? Me either, but I used my factor tree and that helped me find the biggest perfect square, okay? I could have written 4 times 9 times 7 and taken the square root of 4, then taken the square root of 9. I could have done that too, as well. All right, what's the square root of 36? 6 times the negative 4 that's already on the outside of the radical is what? Negative 24. Can I take the square root of 7? No, it's not a perfect square. It's a prime factor. It's only perfect square is 1, and that does not help us. So 7 must stay under the radical. A lot of you are still putting a 6 on the outside and a 6 under the radical. The square root of 36 is 6. It's not 6 square root 6. 6 times the square root of 6 does not give you 36. okay? All right, 19. I'm subtracting, and I have imaginary numbers. So I'm going to distribute that negative sign to get rid of the parentheses. So I have negative 2 minus 2i. Negative times 3 is going to give me negative 3. Negative times negative 8i is positive 8i. Remember, you combine your real parts and your imaginary parts. So my real parts would give me negative 5. My imaginary parts would give me positive 6i. And make sure it's in a plus bi form. And I cannot combine real and imaginary parts. I can multiply them, I can divide them, but I can't add and subtract. Just like when you have regular old variables. Okay? Look at number 21. Now we are multiplying these two binomials together. Okay? So we have to distribute. So negative 2 times negative 1 is positive 2. Negative 2 times negative I is positive 2i. Sorry, I can't see that very well. Negative 2i times negative 1 is positive 2i. And negative 2i times negative I is positive 2i squared. And do y'all remember what you do when you see an I squared? Replace it with negative 1. So that's going to be positive 2 times negative 1. And I'll come back to it. Here, that's 2. And what's 2i plus 2i? 4i. So I have 2 plus 4i minus 2. What's my final answer going to be? 4i, right? Because when I combine these two real parts, they are going to cancel each other out and just leave me with 4i. So don't remember. So don't forget, when you multiply I times I as I squared, you don't leave it as I squared. I is not a variable, it's an imaginary number. It means the square root of negative 1. You replace I squared with negative 1. Okay? And don't let 25 and 27 confuse you. Alright? Just get rid of the parentheses and then combine like terms, your real parts and your imaginary part. Does anybody have questions on those? Okay, so your test will be just like this. There won't be as many problems by far. Okay? You'll have some multiple choice, some not multiple choice. Make sure you know how to factor. You know how to solve by completing the square. You know how to simplify a radical. And you know how to add, subtract, multiply complex numbers. Everything that's on this quiz, that's all that's on your test. If you forget something, go back and look at the old video notes. Go back and look at your notes. Come to tutoring Tuesdays and Wednesdays. The test is Thursday, so Thursday after school is not going to do you any good. Okay? Also, National Honor Society offers tutoring as well on Mondays and Wednesdays for 2 hours after school. All right? So you have the rest of the class to work on this. I'll work on getting an answer key put up so you can check your work. All work must be shown for credit. Don't just bring me next class my worksheet with the problems I have worked out and then everything else with just the answer. That's not going to get you any credit for that. Okay?